So, first thing we're going to talk about the model for a dropped object. Now, this is just if I were to, let's say, put a marker in my hand, hold it here, and just let go of it. This is different than the model for an object which I throw. Okay, so that equation is a little bit different, it has a little tweak to it, which we will learn that eventually. But right now we're just dropping the object. And that looks like h equals negative 16t squared plus h sub 0.
What's a subscript?
Well, a subscript you've seen before in some different formulas. You might see them in chemistry, but even in math, when you learned your slope formula, it's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And in geometry, when you did the area of a trapezoid, it's like 1/2 times base sub 1 plus base sub 2 times h. And so when in math we use the subs, I always
like the first one.
yeah, I always say it's just kind of like a last name. Like, do I have any double names in here? I forget. I don't think I have double. Oh, I have 2 Sierras. So we've got Sierra H and Sierra O. So we've got 2 different last names that we can kind of keep track of them. Okay, and that's all a subscript means. So here is what our variables represent. The regular h is height, and in this model it would be in feet. T represents time, which is usually in seconds, I should say. And then h sub 0 is a specific height. It's the initial height. So if we're talking about a dropped object, okay, if I'm holding that marker in the air, it's at the height that I was first holding it. Now, why are we using the subscript of 0? Leon? Did you have a question, or were you going to make a statement? Okay, then I will let that go. That was weird. Just some like random raising of the hands. All right. Okay, so the reason why we call it h sub 0 is because it represents the height at time 0. Okay, so maybe jot that down. H sub 0 is called that. It's at time 0. Okay, or you could say t equals 0, which is at the beginning, right? In its initial height. It's still in my hand before I drop it. Okay, so that's its starting height. In mathematics, we always assume that the air resistance is negligible. So we're not factoring in winds or air resistance or anything like that. If you're in science, if you're engineering, that's something that we would consider.
It's very important.
Yes. Now, the negative 16 in this formula is one that you'll see often for dropped objects or projectiles, so objects that are thrown or moved with force. And it's really just the gravitational force divided by 2. And we're working with like feet, pounds, our unit system. If you're taking science, they're going to use the metric system. So oftentimes you also see this model, instead of having a negative 16 t squared, it would be negative 9.8 t squared. And that's the model in the metric system. Okay, so just kind of be aware of that. Here is our example. Some of you may have experienced this before in a science class. You have to design something to protect an egg for the egg drop.
I remember doing that in elementary school. I was so pissed off.
Okay, so for science class, students must design a container to prevent an egg from breaking when it's dropped from a height of 50 feet. It's pretty high. Write a function that gives the height in feet of the container after t seconds. So how could we write the function? Yep, we know the initial height. H equals negative 16t squared plus 50. Yeah, we're doing it.
That's part from like the box equation
Yeah, it's a dropped object. I'm dropping an egg.
Why is it 16 then?
That's the gravitational force on Earth divided by 2.
Okay, that's what I was asking.
In our metric, or in our system, not the metric system.
Metric.
By feet.
Yeah. Okay, now there's a follow-up question after you have the model. You could use this model, so I could ask the question, I could say like, Quinn, how or what's the height of the egg after, 0.5 seconds? And then I could ask Emily, what's the height of the egg after 1 second? And I can ask TJ, what's the height of the egg after 2 seconds? And they can just plug in the time and give me the height of my egg at that moment. Okay, but there's a follow-up question here that says, how long does the container take to hit the ground? So we want to find time. Okay, so time is going to be our unknown. That's really great. Thank you, Avery. It's asking the question of how long, so you know you're trying to find time. That means that you must know something about h. If you're on the ground, what would be the height of your egg? 0. Okay, so we're going to plug 0 in. Plug 0 in for h. And then we have studied how to solve that quadratic equation. So 0 equals negative 16t squared plus 50. How would you guys solve? What method? That does not look like a fun one to factor.
No.
Square roots. Sarah, why did you say square roots? Okay. What's a better reason for why we might solve this equation by square roots?
It's a square.
Well, there is a square. There's also a square in the ones that we factor. Why can I square root this one? I don't have to factor it. Kinsey? There's only one t, right? Can you isolate t if there's only one t?
Yes.
Yeah, you just do reverse order of operation. So is there anything you can remove from the side with t that is addition or subtraction? Subtract 50. Now, is there anything you can remove on the side with t that is multiplication or division? How do I move it? Divide by negative 16. So that's going to give me t squared equals negative 50 over 16, which is going to be positive, right? Some of you might have gotten a decimal. What is that? 3.125. So I would say don't round it, write it all out then, because I like what TJ's saying. Like, I would just leave it. What if I have to round it? Then I can just write the fraction. And the last step would be square root both sides. Somebody with a calculator help us out. Second x squared. Okay, so let's round to like the nearest hundredth. How about that?
1.77.
Okay, now some of you have a small calculator or even the graphing calculator. When you type that in, you get the calculator brings up a parenthesis, right?
Yeah.
Okay, so then you could type 50 divided by 16. And you should get 1.77.
Oh, yeah.
Okay? Because we're doing the square root of all of that. Now, what's different about my answer from our answers yesterday and on Wednesday?
Straight line. It isn't negative.
Okay, I didn't put the plus or minus. Why didn't I put the plus or minus today? We wouldn't have negative time, right? So it's just like the rectangle question that we did with Aiden. We're going to only assume the positive because in the real world, that's the only thing that makes sense. Also, notice I went ahead and did the square root on this one. Sometimes I just leave the square root when we're working out problems. Like, I'll just leave it square root 10. I don't really want the decimal. But here, it probably makes more sense to us to say 1.77 seconds than the square root of 3.125 seconds. We don't really know how long that's been. Okay? So if I had asked somebody like TJ what was to evaluate with our model the height of the egg after 2 seconds, what would have his answer have been when he plugged it in after 2 seconds? What kind of number would it have been if you had plugged it in? 2 into the equation. If the egg is on the ground at 1.77 seconds, and I asked TJ to plug in 2, like what's the height of the egg after 2 seconds, what would be true about the H he gets out? It would be a negative number. Okay, so here's something that happens a lot on people's quizzes and tests. They give me answers that don't make sense. So if you told me that the egg had a negative height, what it broke through the ground, okay? No, it would be 0 at that moment, right? Okay, it would be on the ground. It would have already hit the ground. Okay, so your homework assignment this weekend are these problems. There's like, I think 9 of them. And we're going to do number 57 together because much to some people's disappointment, I can't really do every kind of word problem. 100. It's on your gold sheets. You know. What's that? Have I been living a lie?
There's no formula for situations that differ upon every occasion.
Well, I mean, I could do every kind of word problem, but you guys will all be asleep, okay?
Here a long time, I think.
So,
All possible solutions.
I don't want you to come on Monday and tell me you couldn't do any homework on the assignment because you just didn't get any of it. I'm going to question whether you even tried to read the problem. Now, I can understand there could be a problem here or there that you get confused about, but I'm just not going to be convinced that you couldn't answer or write down anything for a single problem. Okay, so this is actually a problem very similar to a problem that we had done before in Chapter 2, but in Chapter 2 they gave us the model. If everybody can just stop talking, we can get through this problem and you'll have some work time. That'll be really great. I don't like competing. I like being the center of attention. Okay. A restaurant sells 330 sandwiches each day. For each 25% decrease in price, the restaurant sells about 15 more sandwiches. Doesn't that make sense? If you lower your price, you sell more?
Yeah.
Okay. How much should the restaurant charge to maximize daily revenue? What is the maximum daily revenue? So revenue is like the money that you would bring in. And of course, when I'm reading this, you've got to make sense of the question. If they're asking about maximizing things, you're thinking about Vertex. Okay, very good. Thank you, Quinn. And they're also talking about something called revenue. So can you describe revenue to me? How do you? Okay, revenue is different than profit.
All the money.
It's all the money that you bring in, and you haven't like paid your workers, paid your rent, paid for the supplies, right? So it's just the money that's coming in. But profit is after you subtract all of your costs, okay? So, you know, how would you calculate your revenue when you're selling sandwiches? The money that you bring in. See how many sandwiches you sell. So I'm going to say number of sandwiches. And depending on how many sandwiches you sell, times the price that you sell them for, that's going to be all the money that you're earning, so long as your workers aren't pocketing anything.
I hope.
So that's your revenue. So we need to write a model that represents the revenue. Okay, so let's talk about numbers of sandwiches. What do you know about numbers of sandwiches in this problem? 330 is what you normally sell.
Plus 15.
And if we lower our price, we're going to sell 15 more, which is a plus, right? Okay. Now, I'm going to say R equals for revenue. Okay, so we're going to do 330 plus 15, but that 15 could change, right? Because I could choose to lower my price by more than just 25 cents. It says for each 25-cent decrease. So we're going to put an X. Avery says, we don't know how many times. Why did I put, yeah, okay. Makes sense. Okay, for each 25-cent decrease, I'm going to sell 15 more. So if I decrease it by 50 cents, I'm going to sell 30 more sandwiches. If I decrease it by 75 cents, I'm going to sell 45 more. Okay, so the X is how many times you reduce the price by 25 cents. Okay, how would you calculate your price? So what do you know about prices in this problem? The sandwiches are $6. They snuck that in there on the sandwich board, huh? Okay, and then what else do you know about price?
Going down by 0.25.
Okay, a 25% decrease, so we're subtracting it. So 6 minus 25 cents X, because like Avery had said before, we don't know how many times we're going to decrease it because we're trying to figure out how we're going to maximize our revenue. Okay, all right, so which equation or which model, which form of quadratic does this look most like? The factored form, which when you go back to chapter 2, we had vertex, intercept, standard. It's currently most like intercept form. Could you get it to look like standard form? Yeah, you could multiply it all out. Okay. Since it's in intercept form technically, okay, I would use my intercept method for finding the vertex. Okay, so you're thinking about y equals a times x minus p times x minus q. And then for the vertex, you start by doing p plus q divided by 2. You remember that? Okay, so chapter 2 doesn't just disappear. We still need to know the information. Okay. Now, in chapter 2, the problems that we were given, we could easily identify p and q because it's just like the opposite of whatever we pulled out. But how we really got p and q was these were the intercepts. So if you set x minus p equal to 0, then x is p. If you set x minus q equal to 0, then x is q. So in this intercept form, we're going to treat it like our factored form from yesterday. Just set both of your factors equal to 0, and you'll find your intercepts. You'll find your zeros of your function. Okay, the things that are on the x-axis, and those will be your p and your q. So 330 plus 15x equals 0. And 6 minus 0.25x equals 0. Maybe I'll do 330 equals negative 15x. Divided by negative 15. What is that x? Negative 22. Okay. Then over here, maybe I'll add 0.25x to both sides. So I divide by 0.25. Dividing by 0.25 is dividing by a fourth, which is multiplying by 4. So x would be 24. And then now I could do the work to do the maximum, the vertex. X equals negative 22 plus 24 divided by 2. Like, those are your two x-intercepts for your parabola, and so the axis of symmetry has to be exactly in the middle of them so that they're symmetrical. So it makes sense to find their average. Okay, add them up and divide by 2. That's 2 over 2, which is 1. What does that mean for if x is equal to 1 in the context of this problem? We should do what? We should lower the price one time by 25 cents. So what's the price of our sandwich now?
$5.75.
Price will be $5.75. How many sandwiches am I going to sell? 15 plus 330, so 345. So what's my revenue? that times that. 575 times 345. You can plug it back into the original equation, that's fine. But in terms of the context of this problem, it makes a lot of sense to me to just like do the numbers, right?
You can't sell
$1,983.75.
How
How-
or something like
How did I get the revenue?
no, it's fine. I figured it out.
Okay. Price times number of sandwiches sold. Okay. So then just make sure that you've answered the question. If I scroll up, and I know some people are jotting that down, but I'll scroll down here in a second. If I scroll up, remember the question was, how much should I charge? $575. What's my maximum revenue? $1,983.75. Now I could certainly lower my price, maybe to $5.50 or $5.25, and I'll sell a lot more sandwiches. But due to like the payouts I'll have to make, you know, the cost of supplies and things like that, it won't be my maximum revenue. Okay. All right, so I have full faith in you that you can read some of these problems and do some work, okay? You guys are all very intelligent human beings. So I'm going to let you loose. The first one on the homework assignment is about selling shoes. You should be able to finish that no problem because it's kind of like our sandwich problem. Okay. So if you need to share a book, send someone over from your pod to grab a textbook from the shelf. You guys can talk about it, can bounce ideas off of each other. And you've got about 8 minutes so you can get 1 or 2 of those problems done for me.